All right, mini exam 5 demo. So I've put my name at the top, and we're just going to go ahead and solve this thing. So academic conduct code, and then we have question 1. We're asked a restaurant's customer wait times follow a normal distribution with a mean of 15 minutes and a standard deviation of 3 minutes. So we know this is a normal distribution. So in the first part of the question, we're asked to take a sample of 100 customers and asked about the sampling distribution of the mean. So we know a lot of things about the mean of the distribution of a sample mean. So we have a very large sample. So this is 100 customers in our sample. So we know a few things. So from the central limit theorem, we know this distribution will be centered on the truth. And then it'll follow a normal distribution with a standard deviation of sigma over the square root of n, where n is the sample size. So this thing, we have 3 over the square root of the sample size, which is 100. So the square root of 100 is 10. And then we have the sample mean centered on the true mean. So this gives us a sample mean that's equal to the mean. And we'll have a standard error 3 over 10 because we have the standard deviation over the square root of the n. Just going through these questions, we're first going to eliminate this one and this one. So then we're left with the choice between these two, and essentially, we're asked about the sampling distribution of x bar. We can think of the distribution of the sample mean. So this is all of our x bars, and we're asking about its center. So we know what the distribution is, the variation in the sample mean is given to us by this thing, but we also know that it's centered on the truth. So we're going to rule out that it's centered on the sample mean, because what we're looking at is the distribution of the sample mean itself. And so the answer here is this one. So we have a mean and a standard error given to us by this question. So this is a little bit tricky, the second part, right? The figuring out which is the middle of this distribution. But because we're asked about the distribution of the sample mean, then we know it's going to be centered on the truth. We don't know exactly where each sample mean will fall, but we know how it's going to be distributed. Okay, so in B, we're asked if we take a smaller sample, so we have 25 customers instead of 100, what changes? And so we know the mean of the sampling distribution won't change. The only thing that'll change here is this n. So that thing will get smaller. So we could actually take the square root of 25 and get 5. So the mean will not change, so this is not the right answer. The standard error of the sampling distribution, that is a possibility. Both the mean and standard error, so again, the mean won't change, and we do know that the standard error of the sampling distribution will change, so this is not going to be true either. So here we have just the standard error. If you run a simulation taking 100 samples, so we're repeatedly sampling with a sample size of 50 each, with a population of, with these two parameters. So we're not told here anything about the shape of the distribution. We just know the population mean and variation. When you plot a histogram of the sample means, you notice what? Well, we know the sample size is pretty large. So it's going to be approximately normal. We just know that from the central limit theorem, and it's going to be centered on 15, and it'll have a variation with we may not be explicitly asked for this, but the sample variation is going to be sigma over the square root of n, which in this case gives us 3 over square root of 50, which let's put that in. Okay, square root of 50. Okay, so no one can read that except me. We're asked, so the shape of the histogram will be approximately what? Well, it's not going to follow the original population distribution. Is it going to be always perfectly normal? Well, it's not going to be always perfectly normal. That's not what the central limit theorem tells us. Will it be normal with variance 9? Well, no, because we have to divide by the square root of n. So actually, let's just calculate the variance here. So the sample variance is just the square of the standard deviation. So this is 9 over square root of 50 squared. So that's just 50. So it's not this one. It turns out it's this one. Normal with variance 9 over 50. Okay, so then B, due to the central limit theorem, we know what? We have population distributions must be normal. Well, this is not true. We actually don't know anything about the population distribution other than its center point and standard deviation. The samples must be the same size. So I'm not entirely clear, like just reading this, what you would infer from this. So it's sort of a confusing option here, which makes me not want to select it. And then the last one, the sample means will be approximately normally distributed. So this is definitely going to be true. So I'm going to cross this one out. There's no requirement on the sample size. Okay, so then we're going to take repeated samples of size n equals 50 from a population and plot the sample means. Which statement best explains what you would see? So what we do know is that when we take repeated samples, we're going to have a sampling distribution, so our x bars, which are going to be centered on the truth. And we're going to have a standard deviation of this distribution, which is equal to the square root of the standard deviation of the original distribution over the square root of the sample size. Okay, so nice. So we have this, and then we're going to look at these options and try to rule them out. So the histogram will look exactly like the population distribution. We'll definitely know. We don't know what the original population distribution is, and we do know what the distribution of this sample mean would look like. So the histogram will be normal with the same spread as the population. So no, it's not the same spread as the population, it's actually much smaller. And then the histogram will be normal with less spread than the population. So this looks like a possibility. And then the last one, the histogram will be normal only if the population is normal. Well, we talked about this actually extensively. This doesn't need to be true. It doesn't need to be true that the underlying population is normal for there to be normality in the sampling mean. So it turns out it's this one. And then, so we can just say something here. By the CLT, we know the sample mean will be distributed approximately normally with mean equal to the original. So this is mean mu, and standard deviation equal to sigma over the square root of n. Okay, so very complete answer there. And this concludes Mini Exam 5 demo. I'll see you in the next one.